First of all, I'd like to thank the team at ESI for this great opportunity today. My name is Kieran Richards, and I'm pleased to share with you some insight into how VR is helping power a cleaner planet within our product design and development work at Cummins Power Systems. I wanted to start with a brief overview of the company. Cummins was established in 1919 in Columbus, Indiana, in the US. Originally focused on diesel engines, it has expanded its products and now identifies as a global technology leader made up of complementary business segments. Cummins has operations in nearly all areas of the world. In 2019, sales were $23.6 billion, and the company employs over 61,000 employees worldwide, with over 50% of those residing outside the US. Cummins is made up of 5 business segments. At the core is the engine segment. This is primarily on-highway products. A recent addition to the portfolio is the new power business. This segment focuses on electrification, fuel cells, and hydrogen-related products and technologies. Then there's the components business, which includes whole-set turbochargers, fleet guard filtration, Cummins fuel systems and after-treatment, as well as the distribution business, which provides services and support throughout our network of distributors globally. And last but not least, the power systems business, which is the area that I work within. This segment provides technology solutions for the larger power nodes, which includes engines, gensets, controllers, electrical switchgear, and much, much more. So in today's presentation, we'll be focusing on VR utilization within power systems. So how is VR helping power a cleaner planet within Cummins? Cummins has set out a vision for the future and recently published its aspirational targets in this area within a document called Planet 2050. This also includes near-term goals for 2030. The high-level aim of the vision is to reduce carbon-based emissions from our facilities and products, whilst also reducing waste. Some areas of focus include the emissions from the engines and technology solutions we provide our customers, as well as the waste that's generated through our operations around the globe. Within engineering, we see VR as an integral part of how we design and develop our ever cleaner products, and also as a tool for developing cleaner, more efficient facilities. By doing more virtually, we can avoid issues, reduce change, reduce rework and scrap, reduce test time and complexity, whilst also reducing the carbon-based emissions that our products and services emit. So let's take a closer look at the VR integration into power systems. VR isn't new at Cummins. The R&D teams, our technical centers in Columbus, have been utilizing VR for many years and established the company's first Cummins Advanced Virtual Environments, or C.A.V.Es. Power Systems has been continually reviewing VR and saw the need within our engineering teams. However, up until 2016, those VR solutions on offer were primarily based around complex, expensive power walls. These have become a bit of a barrier to the deployment across multiple locations. We needed a VR solution that could be easily deployed, scaled, and cost-effective. When C.A.V.E came onto the market, this changed things dramatically. It significantly dropped the cost, the immersive experience that it brought with it more clarity and realism. We developed a couple of pilot sites, one in the UK and one in the US at Seymour. Then with that, we developed these innovation rooms. These rooms that we deployed provided a safe, dedicated VR environment. They were tactically positioned close to the engineering and design teams, and this was the core user group we wanted to target. Each has a viewing area, several large HD screens, whiteboards, and conferencing capabilities, also to aid collaboration. Each room has an operator desk, and in each site we have a primary user who helps set up and facilitate most of the sessions. This helped to boost utilization, especially important as we started to distribute the technology at these key sites. We later expanded our deployment, added another site in the UK, and also sites in China and in India. Just before the COVID-19 pandemic hit. Since COVID, many of our engineering teams have been working from home and are still doing so. This has meant that we've had to adapt and are seeing increased utilization outside of the office environment. Working remotely is highlighting a greater need than ever for VR to allow us to work more effectively in this distributed virtual world. Centralized C.A.V.Es still have their place, but we now need decentralized remote working solutions too. So let's take a deeper dive into some of those core use cases that we have today. For power systems, there are 5 core areas that we've been leveraging VR. And this is where it's providing some unique functionality and value over, say, the traditional tools such as C.A.V.E. These areas include product familiarization, where we can pull up the C.A.V.E. and run through flight paths and cut planes and really interrogate that C.A.V.E. and just provide an opportunity for new users and those not familiar with certain products to be able to get closer to that product. And then also concept generation. That's another key area with enhanced collaboration. Access and removal studies, test cell development, and product integration into these manufacturing facilities, as well as customer tailoring and customer integration. So early in the development of our new products, we've been utilizing VR significantly as part of our brainstorming activities. The ability to walk through models, utilizing those cut planes to evaluate ideas before starting to use C.A.V.E. to model those design concepts has been very beneficial. We've taken these ideas, modeled them in the C.A.V.E. and brought them back into VR for review and evaluation. We've seen many examples like this where VR has enabled a decision on a design that would have traditionally been evaluated with some form of physical prototyping. One recent example was a fuel line design where VR confirmed the design could be assembled and disassembled without us having to spend potentially thousands of dollars on prototype parts and adding 4 to 6 weeks procurement and build time to the program. This evaluation was completed within approximately 2 days using VR. Those evaluations of the design options would have traditionally left us with requiring more parts potentially in the design and additional joints in the system. We've also utilized VR in our virtual design reviews, our collaboration sessions with technical experts, as well as when evaluating designs for assembly and disassembly using standardized and specialized tooling from the production line or in service, like the pictures shown. Checking the ergonomics of a design at one-to-one scale has been a core advantage for VR. Our products are large, and with VR, we are able to evaluate how far a person has to reach or stretch over our products to get to an area or component, and if a user can get their hand into an area or not. Something that I feel is really quite difficult to do in C.A.V.E., at least with confidence. So whilst developing our latest versions of these cleaner, lower emission products, we have been utilizing VR to complete collaborative assessments of the build sequencing. These virtual builds step through each manufacturing stage. We utilize scenes within ICID to help define the build sequences. We were able to get early identification of potential issues, have experts and technicians provide input into the process, all up front of any physical hardware being ordered, and an engine being built, saving rework, time, and potentially saving build issues. We've also used this process to develop any specialist tooling, evaluating our manual handling strategies. These collaboration sessions have involved teams from manufacturing, build, production, engineering, program management, etc. at these multiple locations. We've also used VR for early product safety evaluations, bringing together engineering and safety experts to help complete early virtual safety product walkarounds. Here, the one-to-one scale advantage of VR has helped provide vital insight into certain safety-related scenarios ahead of a prototype build, which traditionally would have been the first time these evaluations could have been done at scale. We envisage some future utilization opportunities within the factory and within the assembly line, as well as increased utilization in reach and repetition studies, as well as within the use of disassembly and assembly of flexible components. So moving on to our test cells, this is another area where we've been utilizing VR. Test cells are a high value premium asset. They're also where a significant proportion of our development costs reside. Their uptime utilization is very important, as well as ensuring they're efficient and environmentally friendly. We have successfully used VR during the development of our latest Tier 4 emissions engines, utilizing the 3D models of the test cells, engines, and new test cell hardware designs. Through these, we were able to assess how we would connect up the after-treatment systems and ensure our test engineers could still work safely within the compact space around the cell. The one-to-one scale here really enabled the investigation and of the operator's reach and access and just general servicing space around the engines within the cell. Based on these VR studies, we adapted our hardware plans, We develop modular solutions and create exhaust systems that were interchangeable to allow us to utilize the cell for various engine product types. We're also looking at how we can do more of this as part of our future programs. We're investigating 3D scanning of our cells to bring in that data and see VR as a core tool in helping us with our future cell upgrades, which could help us reduce our emissions from our facilities. We've also been investigating the use of haptic feedback through the Vive trackers, and would really like to leverage that for collision detection on items such as safety bump packs in the future. So moving on to customer tailoring. Customer tailoring is core to our new product development as well as our existing products. We have been using VR to confirm our systems bill of materials, check compatibility and assembly processes. Traditionally, we may have looked to do a physical build to confirm that systems will fit together. We have many thousands of combinations of hardware options that can make up just an engine. To do this physically is very challenging and time consuming. We're now doing much more of this virtually using VR. This is helping us avoid complex physical prototyping, helping us develop possible solutions before ordering hardware, as well as plan and assess the space claim of parts to a specific build specification. We're also utilizing our OEM CAD data to help evaluate our products in our customer applications. Some areas where we see future VR utilization enhancement opportunities include greater use of those haptic feedbacks through the VR tracking tool, utilization of rapid prototype hardware in our VR space as well for physical component interactions, as well as enhancing our utilization in training and process documentation. So in summary, VR is helping us power a cleaner planet through its ability to support us in reducing our builds and our test times, helping us develop cleaner, more efficient facilities, provides a means to evaluate and virtually verify the fit of a part, saving physical prototypes, as well as catching potential issues before they become real ones. Together, this is helping us reduce unnecessary waste and scrap. VR is helping us do more virtually as we develop our cleaner, lower emission products that are also helping save fuel for our customers and our planet. It's helping us develop our products faster, helping us make design decisions in the virtual world that we traditionally would have relied on physical components to confirm. And it's also helping us work collaboratively as a distributed global team, something we see will be increasingly important for the future. I also wanted to just take a moment to share some additional thoughts and opportunities that I see for the future in our utilization of VR. COVID has changed the way we work. Decentralized solutions VR are going to be very important as we move into the next phase of our utilization. So I see a hybrid mix of centralized C.A.V.E. use and remote home-based use. It's therefore vital that our VR solution is globally scalable and enables simple worldwide access. It's tolerant to these different user bandwidths, that we can maintain security, especially if our users are on different networks and may be independent of our VPNs. That the hardware we adapt and adopt for the future is flexible and future-proof as much as possible. That the installations are easy to set up, can be standardized, and don't create any barriers. And that we can cater for use cases where users will want to follow along with a core VR operator on remote headsets, seeing that full 3D view, or alternatively, watching on a monitor screen. We're expecting to see more and more casual users. We are looking to ensure a shallower learning curve to aid utilization and, where possible, minimize any potential hurdles for those users. So the ability to quickly set up models for collision detection is an area of focus for us, as it's a common use case. We also see opportunities where we could benefit from being able to quickly switch between media during collaborative sessions.